Hi, I'm Jerry Tuskan. I work at Oak Ridge National Laboratory. I'm a plant geneticist, and over the last several years have been working on the domestication of sustainable bioenergy crops, focusing on perennial woody plants. In 1989, I was in North Dakota when the wall fell. I remember watching it on TV. I was actually preparing to come to Oak Ridge National Laboratory. I started in February of 1990. As a young person, I thought that I wanted to be the first priest on the moon. I wanted to do something that would help society and benefit society. Later went on to college, took a course in genetics as a sophomore, and became excited about the use of genetics as a tool for improving issues related to society. I then took that education, got a PhD in genetics, and have been applying them to issues related to phytoremediation, bioeconomy, and it's been very, very rewarding. And I would say that my dream did come true. The wall that my research addresses is the issues related to climate change and the plastics problem that the world is facing today. We're using genetics and genomics to overcome recalcitrance, or the difficulty in using plant-based materials to convert into biofuels and bioproducts. Through the use of modern genetics and genomics, we've been able to identify a path forward to create competitive, cost-affordable biofuels and bioproducts. In our case, we're looking at perennial plants and trying to create plants that are easily deconstructed and converted into fuels and products. Initially, 30 years ago, 50 years ago, the concept centered around the idea that there were hundreds of genes that controlled complex traits. But the innovation that we've discovered using modern genomics is that there are these master regulators, these genes that control the downstream expression of hundreds of genes. So by modifying or manipulating just a handful of genes, we can actually profoundly improve or impact the traits of deconstruction, the breaking apart of the cell wall, and the conversion of those sugars into fuels and products. I think society will benefit from our research in that, if successful, and we can create a cost-competitive alternative to petroleum-based fuels and products, we'll be positively impacting climate change. We'll no longer need to use ancient carbon stored in the ground. We'll be able to replace that with renewable, recyclable carbon in the form of plant materials. These plant materials then offer benefits to local farmers and conversion facilities. And so we create an opportunity for rural development in our country and around the world. The questions that remain unanswered and the things that keep me up at night are actually linked together. We've been spending about a decade of time working towards developing a bioeconomy, but I'm concerned that we're not doing it quick enough. Can we create a bioeconomy in time to be able to mitigate elevated CO2 in the atmosphere? There's a tipping point at which we'll have to address or deal with this issue. So are we spending enough time, are we committing enough resources nationally and globally to be able to confront that tipping point in a positive manner? My mom, my children, my friends, they're concerned about the environment too. And so it's very easy to talk to them. They're very excited when they hear about the things that we're doing here, the research that we're accomplishing. And so it's always fun to interact and meet with the public in general, But certainly my brothers and sisters, family and children, friends enjoyed the conversation as well.